Well, good morning, my algebros. Here is the chapter 4 study guide, solutions. So on the first question, it asks, is it a linear function and is it a function? We can see it is a function, right? And if I know this because if I do the vertical line test, I can see that none of my x's are repeating or cheating. But of course, no, it's not a linear function because it doesn't make a straight line, right? Obviously, it doesn't make a straight line. And that word line is right in there with linear. On number 2, how do we see from a table? Well, I need to have a constant change in x and y's. And as I check my x's, I can see there's not a constant change because it goes up by 3 and goes up by 3 and then by 2. So right now I can stop and say, no, it's not a linear function. On letter B, it is a constant change in the x values and a constant change in the y values. So yes, it is a constant change in both x and y, so it is a linear function. Number 3 is the slope positive, negative, 0, and defined. And as we read a graph from left to right, we see where the end point goes. So number 3 is going to be positive. Number 4 has no slope at all, means it's 0, which is y is repeating, and that's okay. And number 5 is a negative because it ends in negative infinity. And number 6 is an undefined because x is repeating or cheating, so we call this undefined. On number 7, we're going to make a t-table to solve for our x and y intercepts. Let's go ahead and remind ourselves what x and y intercepts really actually are. So anything that is on the x-axis is an x-intercept, or the value of y must be 0. And anything on the y-axis means that the x value has to be 0, right? And notice that the middle point there, that point of origin, is just its own little island called point of origin. So if I want to solve for the x-intercept, then y has to be 0. If y is 0, then negative 8 times 0 makes it eliminate, right? It becomes 0. So I have 6x equals negative 24, and I have to isolate my variable solving, getting negative 4. So I know this point would be negative 4, 0. If I want to solve for the y-intercept, then x has to be 0. So 6x becomes 0, and then I end up with negative 8y equals negative 24. And I isolate my variable using inverse operations and get 3. All right, number 8, we actually use this concept to find out if I'm given this function in standard form of 15x plus 3y equals 45, where 15 minutes for each quarter and 3 minutes for each nickel for parking. So 15 times the x, because x is quarters, and 3 times the y, because y is nickels. On the first one, it says, if Joey only has nickels, that means he has no quarters. How many nickels will he need? So if he has no quarters, which means x is 0, we can solve for the y-intercept when x is 0, when the quarters are 0, solving and getting for 15 nickels. If Gina only has quarters, or she has 0 nickels or 0 y's, we can solve for how many quarters she would need. And we see she needs 3. Okay? All right, moving on. Number 9, it's all about the slope, you guys, all about the slope. And we can see on this graph of Casey's casserole, it doesn't go up by 1, so I can't just do rise over run. I have to look at the change in y over the change in x. So 20 minus 10 over 4 minus 2 gives us 10 over 2, which is 5. And what does this represent? This represents, it's always y over x. So y was fat and x is serving. So it's fat per serving. So it's 5 grams of fat per serving for Casey's casserole. Number 10, what is the slope of the line? Of course, we do our rise over our run, our change in y over our change in x. So we start from one point, and I'm going to start from the bottom point. I'm going up 4 and over a positive 2. And I can see this line is positive. So it's obvious that it should be a positive slope. So y over x, 4 over 2 equals 2. My x-intercept here is -2. My y-intercept is 4. So I can write the slope of the slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. So I know that it would be 2 is my slope and my y-intercept is 4. So y equals 2x plus 4. On number 11, I'm asked to use the slope formula to find the slope given 2 points. So I know that's the change in y over the change in x. And if I have 2 points, there's a first point, which is x and y1, and a second point, which is x2 and y2. So I can just do my differences and my points. 2 minus 1 over 2 minus 1 gives me -6 minus a -2 minus a -6 gives me +4, because the negative is a positive. And -4 and -8 is -12. And I can reduce this to -1/3. On number 12, I do the same thing where I do my differences in y's over my differences in x's. And again, I have that double negative, so I have to add them. And I get 6 over 2, which is 3. Number 13. I'm looking if I have y equals mx plus b, what would be, I have to identify the slope and the y-intercept. On 13, there is no x values here, so I know it would be a 0 slope, and my y-intercept would be 5 because there's no x values, or 0 times x would make the x value go away. On 14, I can see that I have 1 in front of the x, so my slope will be 1, or 1 over 1, either way, and my y-intercept would be 7. On 15, this one, the slope is 6 over 5. And there's no y-intercept, or the y-intercept would be 0. So I'd start there. We would call this a direct variation. Now 16, 17, 18, we are graphing. I'm going to go ahead and use y equals mx plus b, where I know my y-intercept is -2. So I start there, and my slope is 5 over 3. So I'm rising 5 and running 3. I know it's a positive line, and it graphs to be a positive line, so I did it correctly. On 17, I can either use a t-table and solve for my x and y intercepts, but if I glance at this, if I look at if y is 0, x would be 6, and I don't have 6 on this graph. So I'm going to go ahead and solve for y so I can fit it on the graph. I'm going to add 2x to both sides because it's negative, so I use the inverse operation. Then I divide by 6, and I get y equals 26x minus 2. Now again, I don't have 6 on this graph, so I'm going to reduce that slope to be 1/3. But first I start with my y-intercept of -2, and then I'm going to go ahead and rise 1 and run 3 and do that line, because I can't go rise 2 and run 6. There is no 6 on here. All right, number 18, I'm going to go ahead and solve for y, dividing by -4. And I get y equals 2/4 reduces to 1/2, and it's a negative slope. So I should have a negative line when I'm done. And 24 divided by -4 is -6, so I start at -6. And I'm going to look at this slope. Oh no, can I go down 1 and over 2? I can't. It's not on the graph. That's why it's great to know. Instead, I could apply the negative to the 2, rising 1 and running a -2 and graphing that line. Okay, number 19 says if y varies directly with x, So we know that y directly varies with x. So it's always y over x. So if I'm given y is 14 when x is 4, I can write a proportion, right? And I can solve for y because I know what the x value is. I can use cross products and solve for this and get y equals 35. All right, on number 20, I'm going to go ahead and write a function for this. I know that it's always y equals mx plus b, right? Or let me just give myself a little room here, a little space to write. Okay. So I know a function is always f of x equals some sort of slope plus times x plus b. B is my initial fee, where my slope is the fee per whatever, per mile, per candle I'm selling, per candy bar, per whatever ticket. We've talked about this a few times. So let's look at how I'd write this one for this taxi cab service. I know the initial fee is $5 and the slope is $1.25 per mile. So that's that per mile. So x represents how many miles, right? And the cost is going to be y, or f of x. And that initial fee is $5. So what happens if there's 16 miles? That would be $1.25 times the miles, which is 16, plus that initial fee of $5. And 125 times 16 is $20, plus 5 is $25. All right, on number 21, it says, write the equation in point-slope form given the slope of 3/4 and passes through the point of negative 2, 6. So my point slope form is y minus y1 equals my slope times x minus x1. And on here, I know that I have an x1 and a y1. So I know that y minus my y1, which is 6, equals my slope, which is 3/4, times x minus x1, which happens to be a negative 2, right? So I have to address that negative 2. So I would rewrite my equation of y equals y minus 6 equals 3/4 x plus 2. And this would be in point slope form. But why do we use point slope form? We do it to get to slope intercept form. On this equation, you're done here. You don't need to go any further, right? All you had to do was write it in the correct form. But let me just remind you why we're using this form. Because I would usually distribute the 3/4 and I would continue in order to get to the line, right? So I would distribute, and on this one, I have 3/4 times 2, which would be 6/4, which is 3/2. And then I would add the 6 to both sides, adding some fractions here, which means I have to get a common denominator, and I'd get 15/2. But again, you didn't have to do any of this part. This was just putting it in point slope form. So your answer here was right here, okay? But just as a little piece of extra information, if you want to practice that mental math, you could do that. All right, on number 22, now we actually use this point slope form when I'm given a point and a slope. I know I use that point slope form to go ahead and get the equation of the line. And with these, you'll know I didn't throw any crazy fractions in them. So I get y minus a negative 2 equals my slope times x minus 3. I know it's going to be y plus 2. Just remind you, the 3 came from the x1. The negative 2 came from the y1, and the slope came from the slope, right? I rewrite this y plus 2 because a negative 2 is positive. Then I distribute the negative 5. And then I solve for y, subtracting 2 from both sides. And this is my equation of the line. That would go through that point and have that slope. On 23, if I'm given 2 points, I don't have a slope yet, so I can't use my point slope form, but I can use the slope formula to find my slope. And on this one, the slope I get is 2. So then I have a decision. I can use the first point and substitute in my y1 and my x1 and distribute and solve, and I would get y equals 2x plus 2. Or, and this is an or, not an and, I could use the other point, the second point, and get y minus 8 equals 2x minus 3, and distribute and solve, and I would get the same equation because these 2 points are on the same line that has that slope of 2. All right, 24 talks about what's the slope of the line that is parallel or perpendicular to this line that is y equals 4x minus 5. So it's all about the slope, right? It's all about the slope. Parallel has 3 of the same letters reminding us that it is the same slope, the same rise over run. So if the slope of this line is 4, the parallel slope would be 4. And the perpendicular is 3 things. Perpendicular, which means I'm doing more than one thing to it. It's not the same. It's opposite and reciprocal. So instead of 4, it would become 1 over 4 and negative 1/4. So the opposite reciprocal slope would be negative 1/4. So then we use this concept if I'm given an equation of the line, like y equals negative 4x minus 12. That goes through the point 8, negative 2. I need to write a parallel line that goes through that point. So it would have the same slope, but the perpendicular would have the opposite reciprocal slope. I'm not done here yet. I need to go through that point. So now that I've given a point and a slope, I use the point slope form. Do not make the mistake and use this y-intercept. It's not the right y-intercept. It's not the same line. You have to do 2 separate lines from this line. And I'll show you in a graph in a minute what that looks like. So for 25, I do y minus a negative 2 equals my slope, which is negative 4, because it's the same, times x minus x. 8, sorry. And then 26, I'm the same exact equation, y minus 2, because I'm using the same point, equals, though, my opposite reciprocal slope. So instead of negative 4, it becomes positive, and then I flip it over, getting 1/4 times x minus 8. So you can see all the purple is the same because I'm using the same point that they go through, right? This same point right here, let me just highlight that again. This same point that I have to go through. That is why this 8 and this 8 are the same, and this negative 2 and this negative 2 are the same. Okay? All right. Now we go ahead and solve. So I get y plus 2 equals negative 4x plus 32, because negative 4 times negative 8 is positive 32. And I solve that in a minute. Then I do the other side, y plus 2, because y minus a negative 2 is going to be plus. And I get 1/4 x. And 1/4 times negative 8, let me just do it. I can mental math that, or I can do the math of 1/4 times negative 8 would give you negative 8 over 4, which is negative 2. And then I have to finish by solving. Subtracting 2 from this side, getting y equals negative 4x plus 30. And the other one would be y equals 1/4 x minus 4. So let me just wrap all this up together, showing you on an actual graph. Now my graph, because these numbers, these y-intercepts are pretty big, like 30, I counted by 2 on this graph paper. I just wanted you to know that, so I could finish the graphs on here. You're not graphing like this on the test, but I want to just prove to you why it works. The original line was y equals negative 12 as my y-intercept, and my slope is negative 4. So you can see it's a negative line here. Then the parallel line that we solved for, I start at 30, and my slope is the same, and you can see they are parallel lines, right? Then when I found for my perpendicular line, my y-intercept is negative 4, And my opposite reciprocal slope gives you 1/4, creating a parallel line to both of these lines. All right, you guys, we won't have the test until the 14th and 15th. Next class period, your project is due where you get to practice all these things. And I will see you soon. Bye.